All right, today we're going to continue our work on quadrilaterals. Yesterday we talked about kites. Today we'll be talking about trapezoids. We've got some facts that we need to know about a trapezoid. A trapezoid is a quadrilateral with exactly one pair of parallel sides. The other two are not. Those are called the legs. Not a parallelogram does not have the properties of one. Parallel sides are called the bases, and the non-parallel sides are called the legs, just as we can see in our image here. So this is the shape of a trapezoid. Trapezoid's a pretty familiar shape. It's used in a lot of different things. A couple other things we need to know about a trapezoid is, since we have parallel lines, just like a transversal line that passes through parallel lines, angles A and D are supplementary. And hopefully we remember that supplementary means that two angles add up to be 180 degrees. And B and C also have this same criteria. All right, we'll take a look at a couple of examples here. So the first example we see here, it tells us that angle A is 126 degrees, and then it asks us what angle D is. So 126 degrees is here, and then angle D is the one that we're searching for. And again, these are between two parallel lines. Therefore, they are supplementary. So we know that angle A plus angle D combine to equal 180 degrees. So what we need to do is just, again, substitute our values. A is 126 degrees. D is, of course, unknown at the moment. So we just then have to subtract our 126 degrees away from 180 degrees, and we learn that angle D has a measurement of 54 degrees. And keep a few things in mind as we do this. Supplementary angles, if one's obtuse, the other one has to be acute. Example 2, we have a similar idea. Angle C is 71 degrees, and we are searching for angle B. Notice, as of now, we cannot interpret any information on the other side because these are not isosceles trapezoids. So we cannot say, we don't know anything about the other side without any other information. So we know, again, that these are between two parallel lines. So if one of them is 71 degrees, the other one is supplementary to that amount. And 180 minus 71 will give us our angle measurement for B, which is 109 degrees. So we'll throw some algebra into this as well. We are given angle E as 7x minus 2 and angle F as 4x plus 6. It's very important that you always look, we talked about this in geometry a lot. It says solve for x, then find the measure of angle E. So we are going to be looking for angle E when this is all said and done. So we bring our picture a little more in focus here. And these two angles do fall between two parallel lines. Therefore, they are supplementary. Just like when they were numbers, we do the same thing because they're now just expressions. So we're going to set this equation up because the two angles, 4x plus 6, and the angle 7x plus minus 2, should combine. Really, we could use parentheses on these, but we can quickly see that the parentheses are not going to serve a purpose. So I'm going to go ahead and drop those. But together, these two angles combine to equal 180 degrees. Now we just have to do our algebra. We have terms that are alike on the same side here, 4x and 7x, combine to give us 11x. We also see that 6 minus 2 is going to give us a value of positive 4. And we will subtract the 4 away. And then 11x will be equal to 176. And then lastly, we will divide by 11 and learn that our value of x is equal to 16. And then we get really excited because we feel like we got a correct answer. But again, make sure that you read. Remember what we were tasked with doing. We were asked to find the value of, or the measure of angle E. So we'll go back and plug in our value for x, which is now 16. So 7 times x, 7 times 16 minus 2 When we put this in our calculator, we get the angle measurement of 110 degrees. Again, it's very important. Answer the question that's being asked. We weren't asked for x. We were asked for what is the angle measurement for angle E. Next thing we're going to take a look at here is the median of a trapezoid. And the median sounds exactly like it is, and you actually calculate it like you calculate a median. A median is a segment that joins the midpoints of the legs of the trapezoid. So we go halfway down a side, and then halfway down another, and then we connect those dots. One thing we want to make sure that we point out here, that this line will be parallel to the base. Notice we have 3 parallel markings because all 3 of those lines are parallel. This happens anytime you connect the midpoint of a trapezoid. And then the last thing, the median is equal to half of the sum of the 2 bases. Really, median is used in statistics as the average, and we are actually going to calculate this just as we calculate an average in statistics. Add up the 2 numbers, divide by 2. So we'll take a look at an example in here. Make sure that you label these because a lot of times you'll be given the base and then the other base like we're given here, and you're asked to find the median. And then the other value, other times you're going to be given the a base and the median and asked to find the other base. If that is the case, what you want to do is continue the pattern. All right, we can problem solve our way through this. A lot of you probably already know this. 12 and 20 are 8 units apart. Half the distance would be 4, so this value is 16. Those of you that may not be as good at the problem solving skills, that's okay. What we know based on our formula is PQ is equal to half of AB plus DC. That is our formula-based type answer. But we'll plug in our values. Half of AB plus DC, that would be 12 and 20. So our value is going to be half of 32, and half of 32 is 16, which we've already discussed. Line segment PQ is equal to 16 units. And again, half the distance, plus 4 gets me to the middle, plus 4 gets me to the other base. Just think these through, don't overcomplicate these. All right, so here's one we talked about, or just briefly talked about. We have the base of 5, and we have the median PQ of 8. Now, we can go to a formula base. I even hesitate to even show you the formula based on this, because all we have to do is continue the pattern. To go from 5 to 8 is an addition of 3. So to get to the other base, we will also add 3, so we can know that DC, the other base, is 11. But we do have times where this will be algebraic and it won't be arithmetic like it is. So we would have to set this up. And what we would have is the median is equal to half base 1 plus base 2, which we do not know. So that's how we would set this up the same way. We'll go ahead and solve this out. We've already got a lot of the work done. So we would multiply times 2. You may be thinking, well, shouldn't you distribute? You could, but you're making the problem harder on yourself. Multiplying times 1/2 creates fractions that are not there. I can multiply by 2 and then they're gone. And then I just simply subtract my 5 and I learn that x, which I denoted as line segment DC, is 11. And as promised, our good old friend, the isosceles trapezoid. The isosceles trapezoid is actually, I think, considerably easier because it has a lot more congruency involved. But what a trapezoid is, and this is actually a very common trapezoid, the isosceles is, because it's a very strong structure, balance. So in construction, people use this several times. But a trapezoid with legs that are congruent on either side. We can see that that is marked on our figure here. This side is congruent to this side. Now, when we have this, we have a lot of things that are being created once we do this, and this is all very nice for us. We also hopefully recognize that the lines are parallel because that's true of all trapezoids. Both pair of base angles are congruent. So this is usually easy to tell because there's acutes and there's obtuse. So we can see, okay, those two acute angles only on isosceles. Don't confuse this with a regular trapezoid. But on this isosceles trapezoid, those two angles are the same, and so are the top two base angles. Don't mistake base with bottom. A lot of times we think of that. A base just means the top or bottom of the structure. Non-congruent angles are supplementary. Well, that was true about all trapezoids, so it's still true about an isosceles trapezoids. And then the diagonals of an isosceles trapezoid are congruent. So this diagonal line here is congruent to this diagonal line here. The entire line is. It actually cuts it into 4 little segments, as you can see. 4 little segments being here, 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 here. Each of those 4 segments are congruent, and therefore the large segment is also congruent. So when we take this into practice, again, find the missing angles. First of all, let's just do the trapezoid rule. Remember, this angle and this angle are both supplementary because they are, that's called consecutive interior on transversal lines. So they combine to equal 180 degrees. So I do 180 minus 62. And I learn that this angle is 118 degrees. And here's where isosceles trapezoids are really nice. Since these sides are equal, that means the base angles are equal. So that's 118 and this one's 62. Again, use your common sense on these. You're going to have an acute angle and you're going to have an obtuse angle. Make sure the acutes are equal to one another and the obtuses are equal to one another. All right, and then our last question. Of course, we've got to throw in some algebra, right? So let's take a look at this. Side, BD, that is the entire segment right there, is 27. And CA, from here to here, is 2x plus 11. So since this is an isosceles trapezoid, because it tells us so, those two segments are going to be equal to one another. And again, any of these segments could be equal to each other. This segment is equal to this one is equal to this. But we're doing the entire segments. So what we learn is these two angles, or segments, are equal to one another. And in this one, it does ask us to, find the value of x. So now it's just a linear equation. Divide both sides by 2, x equals 8. All right. So there you have it, isosceles trapezoids. I do want to actually back up and talk about something real quick. And that is, nothing in those rules did it say that these angles were being cut in half. So don't invent something that is not true. These angles are congruent to each other, but the diagonals do not cut those in half. That was true of half of the angles in a kite, But do not create things. Have those notes close so you can know the different rules that these things have. All right, you have an example, practices to work on. Good luck.